All right, the third law of motion is what we're going to deal with here. The first two laws were, of course, first one dealt with inertia, which stated that for every action there's an equal but opposite reaction. Second law stated that force is determined by taking the mass of an object times its acceleration. Newton's third law is probably the most famous of the three. Most people can recite that, and that is that for every action there's an equal and opposite reaction. If I want to walk forward, if I want to move this direction, this foot down here is going to have to push back while I go forward this way. So whatever force is being pushed back, that is the force pushing me forward. Okay? So, examples of Newton's third law. We have a spacecraft that has two stages. As it travels, okay, it's gone up in the space, or gone up out of the Earth, and it's now either going to another planet or circling the Earth or whatever. The 4,000 kilogram main cabin of the craft is attached to a smaller 1,000 kilogram extra portion of the craft. Oftentimes it's just used up what they call payload. And it's traveling at a speed of 12,000 kilometers per hour. The extra portion is released by losing its attachments to it, causing it to decelerate at a rate of negative 2.5 meters per second squared, causing the cabin to accelerate forward at what rate? Okay, so here's what we know about this. Since we know that F equals ma, and the force would be the action, if we will. So we have a 1,000 kilogram mass that is released and causes a deceleration of that of negative 2.5 meters per second squared. So that gives us a force of negative 2,500 newtons. Now, how can you have a negative force? Well, we can have a negative force if we use the negative and positive signs as demonstrating direction of where the object is moving. So like when this is released, it's going off backwards, causing the rest of the craft to go forward. So this is going to be the opposite reaction to the 4,000 kilogram craft going on after it's released. So it's going to be a total force of 2,500 newtons. It's opposite but equal. Okay? And this equals mass, and we said that's a 4,000 kilogram mass times the acceleration. So we divide that out, and the acceleration turns out to be let's say 160 meters per second squared. Let's see, 25, oh no. Went backwards with the division, sorry about that. 0.65 meters per second squared. Okay, let's double check my work here. Yeah, 0.65 meters per second squared is the correct answer. Okay, now let's suppose that a woman is sitting on a chair and she has a mass of 50 kilograms, about 110 pounds, and pushes down with a force of 44 newtons. So she's going to push down to get up. Okay, what is her initial acceleration when she gets up? So the force is 44 newtons, and the mass is 110 kilograms. So F equals ma. So if she's pushing down in the negative direction of 44 newtons, she's now lifting up with a force of 44 newtons. So this is going to be 44.0 newtons equals 110 kilograms times the acceleration. So divided by 110, and the acceleration is 0.400 meters per second squared. So opposite equal. Make sure that the opposite and equal values are the same, differentiated possibly by a negative sign, but the calculation is exactly the same from what we've had before. So, 50 kilograms. Man, I got all of a sudden gained a lot of weight. Woo! She's gonna be mad at me. Woo! So, well, let's fix that. Let's make that 50 right here. And then make that 0.880 meters per second. So, alright. That's better. Man, she gained a lot of weight. Woo! Better stop eating those Snickers. So, your practice problems on page 136 in your physics book. 32, just part B of 33 and then 34. All right? Good luck.